So 5, 5 is inequalities in a triangle. And we're going to do a little bit of 5, 6, the hinge theorem. Our objective is to find possible side lengths of a triangle. Use inequalities to make comparisons in two triangles. Relationships between angles and sides. All right, this just makes sense. Okay, what this is saying is the longest side in a triangle is going to be opposite the longest angle. Right? Longest side is opposite the longest angle. And the shortest side will always be opposite the shortest angle. If you look at a triangle, you can tell that. You can tell by looking at this triangle that the shortest side is across from the smallest angle. Everybody got it? All right. Theorem 510. It's just a restatement of what we said. If one side of a triangle is longer than the other side, then the angle opposite the longer side is larger than the angle opposite the shorter side. So in this picture, we have AB is 8, BC is 5. The angle opposite AB is C, the angle opposite BC is A. Which angle is going to be larger? C or A? What? Yeah, C. C is greater than A. If one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Angle A is 50, angle C is 30. A is greater than C. So what can we tell about the sides? What could I say there? Michaela?
AB is bigger than BC.
No. AB is across from 30. BC is across from 50. Allison, what would you say? Not sure? Sydney?
BC is greater than AB.
Yeah, BC is greater than AB. The longer side is across from the larger angle. So BC is greater than AB. List the sides of triangle PQR in order from shortest to longest. What would be the shortest side in this triangle? Allie? Yeah, QR. It's across from 45. 45 is the smallest angle. So QR would be first. QP would be next because it's the across from the 55, and then the one across from the angle from 80 is PR. All right, any questions? Okay. List the angles from smallest to largest. What's the smallest angle? Yes. Okay. Why did you say B?
It's across from 6.
Yep, 6 is the shortest side, B is across from it. Smallest angle would be B, the middle angle would be C, it's across from 7, and then A is across from the longest side, so it would be last. Any questions? All right. So here's an application. You're constructing a stage prop that shows a large triangular mountain. The bottom edge of the mountain is 27 feet long, so let's label that. This is 27. The left slope is 24. And the right slope is 20. You're told that one of the angles is about 46 and one is about 59. We don't know what is what, right? What angle is the measure of the peak of the mountain? So we would have to find the third angle of the mountain. So we've got, if one is 46 and one is 59, we don't know if 59 is the largest or the medium one, right? We don't know. So we would do 180 minus 46 minus 59. So that's the same thing as 180 minus 105, which equals 75. All right. 75 is the largest of those three angles. Between 46, 59, and 75, 75 is the largest. We know the largest angle has to go across from the largest side, and the largest side is 27, and that's the peak that is across from it. The peak angle would be 75. All right. Everybody got it? Okay. Triangle inequality theorem. The triangle inequality theorem says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So we can say we know that AB plus BC, when I add those two together, that's going to be greater than AC. I know when I add BC to AC, that's going to be greater than AB. This makes sense because, think about it. If I had a triangle, that's the third side, and the other two sides are not greater than the third side, then they wouldn't touch, right? If their sum is not greater than the third side, they wouldn't reach each other. Or if they're equal to the third side, then they'd just be the same line, right? So these two have to be greater than the third side. A triangle has one side of length 14 and another of length 10. Describe the possible lengths of the third side. Okay, to do this, I'm going to tell you an easy way to do this once we go through understanding the idea. Because there's a very easy way to do this. But the long way to do it is we can draw, there's two possibilities. we can have a triangle where 10 and 14 are the shorter legs, right? So that would look like a triangle that looks like this. So this is 10, this is 14, right? We need, and the third side is the unknown side. It's the longer side. Or we could have, so what, if this is the case, let's talk about this one before we go to the next one. If this is the case, the sides are 10 and 14, what do we know about the third side? What does it have to be greater than? I mean, what does it have to be less than? Sorry, what does it have to be less than? The sum of the sides, yeah. So this, if we call this x, x has to be less than 24. Has to be less than 10 plus 14. Another way with these possible lengths that the triangle could be is that 14 is the longest side. This is 14. One of the shorter sides is 10. We've got to find this side. Okay? So in this case, what would the shorter side have to, what would this x have to be greater than? We remember our rule. The sum of the two shorter sides must be greater than the longer side. What value of x would make the two shorter legs greater than 14? Just give me a value. Don't worry about the inequality. What's a possible value of x? Is 3 a possible value of x? No. Then the sides wouldn't touch. Is 5 a possible value of x? Yes. 10 plus 5, 15. That's greater than 14. So the cutoff point would be what number? Not 5. 4. Yes. X is greater than 4. Okay? And then what you do is it didn't write, there you go. We've got x is greater than 4. Then we have to write this as a compound inequality. We can put x in the middle. So 4 is less than x is less than 24. Right? That's the same thing as these two together. Right? Same thing as saying x is less than 24 and x is greater than 4 would be x is less than 4 is less than x is less than 24. Now, that's the long-winded explanation. If you have a problem like this, you can just think of it like this. Let's clear this out. And they give you possible lengths. You take 10 plus 14. That equals 24. Right? And then you subtract them. 14 minus 10 equals 4. Those are your numbers in your inequality. 4 less than x less than 24. Yes?
We have like x plus like, I don't understand. What's going on?
Okay.
But what?
So x, the third side, in this third, so it's x plus 10 must be greater than 14.
Okay.
And then in the second one, it would be 10 plus 14 must be greater than x. All right, does everybody understand this? So add the values, subtract the values, put x in between their range. Yeah, if you're trying to fill in your notes, I'll do this real quick. So this would be x plus 10 is greater than 14. So x is greater than 4. And this second one would be, they don't have the picture, but it would be 10 plus 14 is greater than x, so 24 is greater than x, where x is less than 24. The triangle has a length of 11 inches and another of 15 inches. Describe the possible lengths of the third side. All right. Let's do what we just talked about. What would that x, so we've got x is going to be in between two values. How do I know, right? So how do I find my large value? Add them, right? 15 plus 11 is 26. How do I find my small value? Subtract. 15 minus 11 is 4. That's it. That's all there is to it. I'm done. All right. Any questions? Okay. The hinge theorem. The hinge theorem says, if two sides of one triangle are congruent to two sides of another, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. This hinge theorem is just, it makes sense. Say that, okay, let's say I want to make one arm shorter than the other. So this is a longer arm, this is a shorter arm. Okay? So in this, I'm the hinge, right? So if I have these, my arms are the same. I mean, I've got my arms here, and I make the hinge, and this hinge is this wide, right? Then if I widen my hinge, so I still have my arms. Let's say I widen it out. The arms are same length. Then, if I make this angle bigger, then the third side is going to be longer. See what I'm saying? Here, same length. I take these. This is a smaller side. This angle will be smaller. If I widen the same length out, then the third side is going to be longer. That's the hinge theorem. Okay? So, here's an illustration. We've got these sides are marked the same distance. The only difference is this has an angle of 88 between them. This has an angle of 35. Since Vx is across from a larger angle, then it will be greater than St. Hinge theorem. Questions there? Okay. Converse. Converse works just the opposite. So if I have two congruent sides in a triangle and two triangles, so these two triangles have congruent sides except for the third side, then the larger angle is going to be across from the longer side. 12 is across from C. 9 is across from F. 12 is greater than 9. So C will be greater than F. Everybody got it? Let's do an example. We're given ST is congruent to PR. How does PST, so how does this angle compare to this angle? Right? What else should I mark congruent in these triangles? Sitting. PS is congruent to itself. All right, let me get rid of these angle marks. Those are confusing. Okay, so we've got the situation. Which angle is going to be larger? PST or PS? SPR? Which angle would be larger? Megan. Yeah, why, Megan? Exactly. 24. Everything is the same except one triangle has the side 24, one has the side 23. 24 is greater than 23, so that angle across from it's going to be greater. So my answer would be PST is greater than SPR. You don't need to write down all that solution stuff. The answer is fine. All right, questions? Another example. PR is equal to PS. The measure of QPR is greater than QPS. So let's show that by, we'll give QPR 2 marks. And we'll give QPS 1 mark. All right. What else do I want to mark congruent in these figures? Sydney? PQ is congruent to itself. All right. So which side is longer? RQ or SQ? And why? Alec? Yeah, this angle is bigger. The angle with the dot is bigger. So RQ would be greater. No, RQ is greater. My last example. If PR equals PS and RQ is greater than SQ, so let's show that by, let's say RQ has 2 marks and SQ has 3 marks. No, RQ is greater, so RQ has 3 marks, SQ has 2 marks. They share side PQ. Okay? Which angle would be greater, this one or this one? Which angle would be greater? Braden, what do you think? RPQ, right, because it's across from the longer side. Oh, RQ, I marked that wrong. RQ was less than SQ, so I marked it wrong. RQ would be the shorter, and this is SQ is longer. So, yeah, SQ is the larger side, so this would be the larger angle. So it would be SPQ is the larger angle. All right, any questions on the notes? No questions. Very good.